In the last video, I designed this spray cooling duct for my GR86, and I figured out how to secure it to the knuckle. However, there are some things that I cannot test on the knuckle alone. Furthermore, it's pretty hard to visualize how everything works. For starters, I was holding it in the wrong orientation for the duration of the video. It should be like this. And secondly, all the important components that dictate the shape of this vent, like the brake caliper, is missing from this knuckle. Now, originally, I was going to show you guys a diagram or some visual item, but it would be faster if I just showed you how this works. Now, reminder to not get under your car if it's only held up by a jack. If you're gonna do something under it, it's gotta be on jack stands. But we're gonna be okay, so come here. So this is our front caliper. Kinda dusty. And our vent will mount here. As you can hopefully see, there is a gap here between the caliper mounts and the rotors. And that is where we will be directing air into. Here, let me put the actual vent on. Here are the magnets that were mentioned earlier, and they just snap on. Notice how this vent curves around the front caliper, and this bolt here, it's not touching anything. And it intakes to the inside of the caliper. It's hard to tell since the front is lifted, but this surface is actually pointing down. This points down, so it scoops air up from underneath the car a little bit. One of the design constraints was accounting for aftermarket calipers. Aftermarket calipers usually are a 4-piston instead of just a 2-piston. But the thing is, this is a sliding 2-piston caliper. The 2 pistons are on the inside. So if this vent clears the inner side of the caliper, it should work with aftermarket calipers as well. I did some rough pixel measurements, and this side of the caliper is about the same thickness as most aftermarket calipers. Obviously, relying on magnets alone would not be a good idea, so let's go get these aluminum rods attached. Now, I have already gone ahead and replaced this guy, with a longer JIS, or Japanese industrial screw, and we will be using this to mount the rod holders. And here are the aluminum 6061 rods. Alright, so top one's in. These suckers are in. This part's a little bit tricky, you kind of have to give it a push, and then it goes in, snaps in. Don't forget the washer, or else this is going to explode when you tighten it down. And that should be it. Cool. So this is how it looks like from the top. As you can see, it goes around the caliper and scoops up air. Actually, let's get the wheel on, show you how that looks like too. This is how it looks like with the wheel on. Note that the car's still lifted, otherwise I can't get my hand down here. There we go. Here's how it looks like. So this is the wheel, it's inside of the wheel, inside of the brake caliper. Actually, let me see if I can get this on the ground. Okay, this is how it looks like with wheels on the ground. No, you can kind of see it. This little green guy sticking out from the edge. Okay, one last try. Oh, that's good, it's good. I just can't use the tripod. Anyways, here is how the sucker looks. Notice that it's inside of the wheel, and if you run a wider wheel, so should be good. This is stock OEM wheels. I'll put in the dimensions of the tires in the caption. You can run a much wider wheel and it'll still have some fresh air sticking out from the inside of the wheel well. So it fits. Full send. Let's test it, right? No, we can't. You see, these ducts are printed in PLA, or polylactic acid. And while PLA is easy to print, it has a melting temperature of 150 degrees Celsius. But when it comes to these polymers, the melting temperature isn't the primary limitation. Instead, it is the glass transition temperature. You see, when a material like PLA reaches this glass transition temperature, it doesn't necessarily become a liquid, but instead it becomes a lot more soft and malleable, and it loses all of its stiffness. This isn't particularly good when you're using said material in a load-bearing application. PLA has a glass transition temperature of around 60 degrees Celsius, plus or minus maybe 5 or 10 depending on the brand you're getting. This combined with the fact that brake rotors could reach a temperature of 150 degrees Celsius on highway driving makes it pretty clear why this is a bad idea to actually test on a real car. It's just gonna melt or lose all of its stiffness. So what do we use instead of PLA? ASA would be a good start. It has a glass transition temperature of around 100 degrees Celsius.
Wait, what's that? PPSCF. Ultra high heat resistance.
Heat deflection temperature of 264 degrees Celsius. Okay, yeah, that's pretty hot.
Flame retardant?
Me too. Ultra low water absorption. Can relate.
Wait, how much is it for one roll? And that's only for 0.75 kilograms?
You know, I think ASA is a good starting point. Even if the rotors reach 100 degrees Celsius, it's not like the ducts are physically touching the rotors. So let's start with that. Okay, so I got myself a roll of ASA. All I need to do is throw it on the printer, right? That would work for some people, but my printer is this. This is a Prusa i3 Mark III S Plus from 2022. And it served me pretty well for the last 4 years. It's what got me into 3D printing, CADing, and just tinkering as a whole. But it's missing some key features. You see, it prints about as slow as iDrive. This bed slinger is missing a lot of newer technologies, such as input shaping, closed loop servos, and much more. The key feature that it's missing, for me, is an enclosure. You see, certain filaments need an enclosure to print at higher temperatures. And this ain't enclosed at all. Combine the need of an enclosure with my desire to print engineering filaments like PPS-CF, and I've landed on the Bamboo H2D.
This guy's got a much larger print volume, coming in at 350 by 320 by 325 millimeters. And most notably, the print head has 2 nozzles. But what really matters to me is the fact that it comes with a heated and filtered enclosure. This is what's going to unlock my ability to print with higher temperature filaments.
Now, I know it might seem a little overkill to get a printer with dual nozzles when I'm printing an item in one filament, but the idea is to use one nozzle with a cheaper filament for support material, and the other nozzle uses more expensive engineering filament. Can't afford to waste any of that good filament, you know. Didn't I start this entire project because I thought upgrading to a big brake kit was going to be too expensive? Well, oops, I guess. Because I'm not allowed to leave my printer in the garage, the next issue is air quality. You see, this is my old setup, right here, just without the H2D. So there's a Prusa Mark III, and then there's this window fan. So this is how it looks like. We have our window fan with a massive adapter that brings it down to a 4-inch duct. And this side will be on the other side of a window. And because it could barely move the air, I added a little PC fan to suck out whatever's in the duct. For PLA prints, this worked fine enough, especially because I just opened all the windows and left the room. But for ASA, I'm going to need to take air quality a little more seriously. This fan here sucked. Or rather, it didn't. You see, there are different kinds of fans. Static pressure versus airflow. And this right here is an airflow fan. Airflow fans, such as these, move large amounts of air in open space. their fan blades tend to be steeper and not overlap as much. Static pressure fans, on the other hand, tend to have more overlapping blades, with each blade at a less steep angle. The issue is, if you constrict the airflow of an airflow fan, like I did with this massive adapter down to a tiny 4-inch diameter duct, it's not going to move that much air. And in my case, it actually moved air in the wrong direction. Now I'm going to hold this paper towel up and bring it to the exhaust of this duct, and you can see it's barely doing something. This fan is barely sucking and blowing. And even more concerningly, if I bring it up to here, it's actually pushing the paper towel away in certain spots. This isn't sucking. This is blowing. Only if I line it up. Now in the middle it kind of sucked the paper towel against its, but on the edges here, it's just blowing the paper towel back, and realistically, whatever plastic fumes I have is being pushed back into the room. So what I really need is a static pressure fan that can move a lot of air through a medium or small sized duct, maybe a 6-inch diameter duct instead. So I knew this guy that was a plant enthusiast, if you know what I mean, and he used to grow these plants indoors. Now, in order to keep the air odorless and breathable, he had one of these. This is an inline fan. Specifically, this is a Cloudline T6 from AC Infinity. I'm not sponsored. So this fan could move over 402 cubic feet of air per minute. Now, that's enough airflow to exchange all of the air within this room in under 3 minutes. It's a pretty powerful fan. All this fan needs to do is remove the air from underneath this table, which has both of my 3D printers. In order to do that, I printed two things. This is a table adapter. What it does is adapt that 6-inch diameter duct into a little slot, or I should say medium-sized slot, to suck up air from behind the 3D printer. So on the other side of all of this ducting is this sliding door attachment. It takes the 6-inch diameter duct and exhausts it in a way that snaps in to this sliding door frame. Now, to prevent the air from just going up and back into the room, I angle the exhaust towards my track tires. So it looks something like this. Hopefully, most or all of the exhaust air will come out into the balcony, into the side, and not back into the room. In the meantime, I'll figure out how to block this whole section off. Now, some of you may be asking, why not attach that duct directly to the H2D? The first reason is this top vent. This top vent opens up when printing lower temperature filaments such as PLA. Oh. Yeah, and it's pretty loud. Having the fan attached directly to the H2D will not capture these exhaust fumes. This will just be propagated within the room. And the second reason is I also want this duct up here to exhaust whatever fumes coming from my Prusa Mark III. Both of these printers are still going to be in use. As I mentioned earlier, this fan is really powerful. I'm going to see if I can visualize this. So it's hard to see, but this duct ends up sucking air from back here. I'm just going to bring a paper towel close to the intake, which is right under this guy. And you can hear it violently sucking on that paper towel. Nice. Now, to make sure that the exhaust from the printers don't escape into the room, I will block off the front side of this table here with just a large piece of cardboard. This shouldn't be too much of a fire hazard, given that the H2D is fully enclosed and that the Prusa i3 or Mark III is farther back into the table. But something I'll keep an eye on and probably improve on in the future. So here we are. The brake duct fits. We got a new printer that allows us to print with higher temperature filaments. We got an upgraded ventilation system. All that's left is to print this with ASA. Be sure to like, comment, and subscribe, because the next video is where we find out if all of this work pays off. Until then, take it easy.